Wow. I missed 4 days in a row. Oops. So, I missed Friday because I started making it a card game. I want to implement my idea real quick before I forget. Using a hash map. Hmm. Alright. This guy. Uh. Yeah. Entry. Hash map. Uh. Instruction. Uh. Mm. Kind of doesn't work already. This might not go very well with coffee. It's a pizza bagel. So I was thinking I can make it so I don't have to clone next state. Hmm. Okay. Um. Um. Indeed. Okay. Okay, so this doesn't work because the path is the path and not the hash map. Alright. Okay, I tried my idea. Okay, check it out. Hello, game. I will call this. Alright, here it is. Here's the card game. Card game. Ah, crap. Alright, are you ready to play card game? Holy moly. There it is. So you got the game seed. You can input that to play the same game again. And that tells you your score. And then how much is in your stock. This is the waste pile. And this is like the foundations where you have to stack the ace, 2, 3, 4. And then these are your tableaus. And how do you move? Oh, you click. No, you don't. You type T3 onto T4. And now it's gone this 8 onto this 9 here. Wow. There it is. T5 onto T4. T5 onto foundation 1. T6, T1. Yes. 6. Let's go. Foundation 2. Wow, T5 is loaded. Yeah, so I made this card game over the weekend, and it was very fun. Very fun. I had a really good time making it. Oh, looks like we have to move the stock. Oh, I forgot how to do it. You can also auto move, but let's see. Am I missing anything? Is it gonna auto move on me? No. Okay. So yeah, we have Terminal Solitaire. I made this because my friend made a solitaire game. I can open that one as well. Called Rusty Solitaire. Already up to date. What? Why didn't it do it? Hello? Okay. Okay, well, that's gonna take a second. And it's made with AI because he is not actually a programmer. Terminal Minesweeper. So, how do terminal applications where you can click on things work? Like this. Kill. You can just click on these things and it works. I want to know how that works. Terminal click how? Detect. Alright, bud. H top. How does that work? This is a mirror? Maybe. Click. Search. Click. Line editor click. Click, click. Key mouse bar click. Synthetic event mouse click in the function bar. My buddy. Yeah, so basically, my friend made a card game, and it was buggy, obviously, because it was made by AI. And I made a card game before in Love 2D, and that was a fun project. Now I know Rust. Why don't I make a card game in Rust? And I'm like, wow. Card games are so simple and strict. Hey, there's a game. 300 modal UIs. Yes. Alright. Okay. Yeah. Got it. Settings. Achievements. Okay. 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 What? Did I mention it's buggy? The entire cars move. Yeah. So, what happens sometimes is the game will say, you lost. There's no more moves. But there's just obvious moves you can do, like the ones I've been doing here. So that was annoying, and I wanted to do that. I wanted to make a library so that, and like make it as baby proof as possible so that the AI can't screw things up. Um, yeah, you should make a card game. Card games are a really fun programming project. I'm gonna recommend my friend make the card game as well. I can't believe how soothing it is. Crap. I I remember seeing my grandparents always playing card games, and I was like, why are you guys always playing card games? To myself in my head. That's boring. And now I'm like, solitaire. Oh. Am I gonna win or am I gonna not win? I should have put down that other king. Rah. Yeah, that would have helped. Well, there we go. Sure. Uh, yes. I'm just playing cards now. Let me just win the game, and then I'll start coding the game. Just one more. Just one more. Where's the 8, man? Alright. Now we're off to it. Or not. 6, 7, 10. Was there a jack in there? I think I might have lost. That sucks. Oh, that was a 6 actually. Go back. There we go. Oh, there we go. Yeah. 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 9, 5. Probably. 5. There we go. There you go, bud. Oh, come on, dude. Really, dude? You're gonna make me. What was that? It's so buggy. Okay. So, what's missing from the game, or from my version of the game, is like, first of all, making it kind of nice. Well, as nice as you can get on a terminal. Cause like this is sideways, right? I'm not gonna just play solitaire. Exit. Solitaire stream. Is my cheek like particularly beardy? Yeah. So, uh, let's look at it because it's cool. So I have this game trait. I feel like it should be separated into multiple traits, because this one is like probing the game, and then like this is like the core of like running the game. So probably like this is probing the game. So I can have like a trait for. I mean, this is kind of. If you want to the game to be able to automatically play. I mean, it's nice. Nice enough. Suit. Wow. Insane programming skill. Let's go. Card rank. This is actually something that AI got a leg up on me. I had this thing, card value. Where is it? Help. Card value. So I had like this, where it's like a U8 for cards, which like, well, no, this is like the card itself is a U8, but it has four, or it's three packed values into one byte. So you use 4 bits for the card, which is from 1 to 13. Then you use 2 bits for the suit, 2 bits for like which deck it's in. So we saw deck, there's 4 decks. Suit, there's 4 suits. Ace, 2, 3, 4. And it's also non-zero for like extra fun, rusty fun. So my card is 1 byte. And then the AI that wrote my friend's card game, the card was 8 bytes. So mine is 8 times better. I'm 8 times smaller than AI. That's how it works. So you have a card stack. And I'm using an ArrayVec, so it's stack allocated instead of heap allocated, because it's better, faster, stronger. And then you have a pile that has face down cards and face up cards. So the card itself doesn't know whether it's face up or face down. It's purely the placement within the game that determines whether it's face down or face up. And like, I suppose you could have some sort of other thing determining that, but so yeah, there's a card pile, and then that's pretty much it for like the card data structures. And now it gets into this like game session thing where it's like tracking your stats. You have a configuration for the game, and then what it does is it provides a history, so you can undo. But that's basically it. And it like tracks the undos in the stats. Yeah, the way it undos is it replays the entire history of the game, which is very fast when it's a card game where you play less than 100 moves. So it's kind of just not a problem. It's cool and fun and simple. And then on top of the card game library, we have this Klondike library. We still don't have any graphics. Okay, it is freaking hot. Okay, so it has a config. You can either draw 1 card or draw 3 cards. Keep track of your freaking Windows XP cards, Klondike score, how many times you've cycled the stock, and how many moves you've made. And then Tableau is like, you know, probably easy, good and nice. Tableau is like these things: 1, 2, 3, 4, 5, 6, 7, and then this is the stock, and then these are the foundations. So I have this enum for which Tableau you're pointing at. And then I have this next function that gives you the next Tableau. So if you're on number 1, it goes to number 2. Number 2 goes to number 3, etc. And then, there's no next one, so it's none. Same for foundations. You have the next foundation. And then here we have an enum that represents any pile. So maybe it's a Tableau, maybe it's foundation, maybe it's the stock. And then this is like a thing. Wait, rep or U8? What am I doing? I don't need that. So this is a stack of cards. So we have some face down cards, and then we have one or more face up cards. And this skip cards thing says skip the bottom few and just take the rest. And that's a tableau stack. You can only move a stack from a tableau. Or on to a tableau. You can only move a stack to a tableau. But you can also only move a stack from a tableau. So that's represented in the data structure that defines which moves are possible. And I also have this next function because we're going to iterate over all possible moves. So this is a pile with tableau stack instead of just a single tableau. So this is a description of moving a card into a foundation. The source card can only be a single card. And then here's the description of moving card into a tableau. The source card can be a stack if it's from a tableau. Otherwise, it can't. So I've exactly modeled the possible moves in this enum. So a Klondike instruction can move into a foundation exactly one card, or it can move into a tableau a stack from another tableau, or exactly one from elsewhere. Or you can rotate the stock. And this is an enumeration of all possible moves in a Klondike game. And I still have this next function that will, if you keep going next, will iterate through all possible moves. And then you have useless moves, like moving a foundation to a foundation. And then here's the game state. It is 336 bytes. I'm pleased with that. That's the entire game state. So it's fast to memcopy. And you can see all the tableaus are different types, because the first one, it's not possible to have face down cards. It's always speed per jump round up if you get like 3.5 or 4.5. I don't know. I imagine it uses the display macro, or it's not called that in Lua. Format. So whatever that does. Why don't we take a look? Why not? Gauges. Okay, so you said SPJ. Is that? Yeah, so it's using the format macro. It's not a macro. It's Lua. Format function. Which one is it? Speed. It's showing 2 decimal places. Speed. Does it matter? It's showing 2 decimal places. It's not showing a whole number. I didn't think really hard about it. It just formats the number to 2 decimal places. It would be good to know. String not format. What is this? Formats as a floating point value. Is it? I guess we could literally test it. Check it out. Wow. String format. %O2F, and then we do 3.141, and then 3.15, 3.14. There you go. It rounds. In CSS, it shows to 1 decimal. Well, the speeds are much higher. They're like 800, right? They're approximately 16 times higher. All right. So there's like 2 important pieces of code for the card game. This one, which does a move. So this is what we just looked at, where it's a move that goes into a foundation, destination, or into a tableau, or it rotates the stock. So this actually does the stock rotation. So if there's no more face down cards, it flips it and then reverses it, or it draws a certain number of stock cards. Uh-oh. Oh no, there you go. We're good. And then if you're moving into a foundation, it takes the top card. And then if you're moving it into a tableau, it takes a stack. So you can move a stack if you're moving into a tableau, but you can only move 1 card if you're moving into a foundation. So the way the game works is like baked into the structure of the program. Instead of like validating and being like, I think this is right, and then it breaks, it's just impossible to generate an invalid move. So that's the thing that actually does the moves. Here's the other important code right here. Is instruction valid? So if there's no stock, you can't rotate the stock. And then if you're moving into a foundation, well, it grabs the card you're trying to move. There's only 1 card. And then it grabs the card you're trying to move on top of. And if there is a card you try to move on top of, is it the same suit? And is it the value +1? So are you trying to move a 2 onto an ace? And then if there's no card in the destination, the foundation that you're moving to, then it has to be an ace. Simple. Otherwise, it's a legal move. You can't do an illegal move. And then if you're moving into a tableau, then you're moving a stack. So it looks at the bottom card of the stack you're moving, and then the top card that you're moving it on top of. If the destination card is a different redness and is 1 less than the card you're moving it from, then it's allowed. If you're moving it onto an empty tableau, then it has to be a king. Otherwise, you're not allowed. Simple. Done. That's the whole game. So it's very structured and rustified, and I am super pleased with how it turned out. But it's also a very easy programming project. cards rustified at last. Finally. Oh yeah, here's how it makes a new game. You make a full deck, shuffle the deck, and then it pulls N cards, D's nuts cards from the deck. So this is the down number of cards. That's D's nuts. So each tableau has a different number of D's nuts, face down cards. And so that's a const generic here. D's nuts, D's nuts, D's nuts, and then you have 0, 1, 2, 3, 4, 5, 6 face down cards taken from the deck. Takes it out of the deck, puts it in the stack, and then it makes a pile that's face down, and then it puts a card face up, one additional card face up. So, yeah. And then it does that 7 times, and then the rest of them just go into the stock, and that's it. Foundations are just empty stacks, and very, very, very easy. You love to see it. This was a very relaxing programming project. What I'm hoping is that my friend can get the AI to switch the backend to use this, and then there will be no more bugs in the game. But he hasn't done it yet. Did I rep or anything? No, it's the only one. My bad. Okay. Does that change the size? If we go up the thingy, Klondike instruction, no, it's still 4 bytes. Unlucky. You can probably pack this into 1 byte if you try hard enough. Let's see. 3 times 4 times 13. Yeah, that works. So if I wanted to serialize a game as tiny as possible in like 100 bytes, you could have the seed and then 1 byte per move. I guess you could go even smaller, but like, what's the point? Cool. Oh, stack. Crikey. No, you can't. Because that's now 3 times... Oh. 3 times 7 times 3 3 times 7 times 3 times 7 times 12. Is it 12 or 13? It's 13. Where did it go? Yeah, that's too big. There's too many variations to fit into a single byte. 7 times 13 is tragic. Just this one, it's 7 times 13 times 3, which is more than 255, I think. 273. It doesn't fit in one byte. Tragic. I can't believe this. You're telling me I can't fit this into 1 byte? Yeah. Well, I wanted to work on... I had an idea for this, and it didn't really work out. Does that work? Maybe it does. Maybe I use the session and I don't need the path. Let me try that. So if I use a session, then it's like none of that. This becomes yeah. So this is hash map. This is renamed to moves, state moves, and then dummy stats. Don't need it. State is just self clone 999. Possible instructions. Yeah. Path is part of self. Oof. Okay, so while we don't win, we do entry dot state. What is that? Is that a Klondike? It's a G. I think so. Clone entry or insert right. Indeed, it's this. Can we actually just smash the iterator into there? We can, but I want a vec because I want it to be sorted. But we'll start with this. Okay. Okay, so this guy is so there is, this is a reference to the old iterator. Can you do this? I don't know. Okay, so then the next state, we don't need to do anything. We can just zoop, and then it's good to go. If right. Right. It's saying maybe I should go by states, because like both of them are tiny. Okay, yeah, don't need to do this. You're good to go, man. Clone it. Boom. So then we don't really care Yeah, because it just happens the next time. Um, um, Widow away. Do we do if let? If let continue? Maybe. Some. Then state. Just do it, bruh. And then continue outer just is easy peasy. And then else undo. We kind of need to do something different here, though. Kind of. This isn't. This is easy, right? It's cloning the state. Ah, jeez. Hello? Oh. Go away. So in the little gamey game, all this does is create this object and filter it. That could be pretty teeny weeny. Cause like this is cheap. This is cheap. This doesn't do anything until you ask it what's next. So this is a pretty cheap function call, but maybe I'll still do this. There we go. That's awesome. So if we've already observed the state before, we've kind of gone backwards, and we could collapse the history or not. Undoer. What do you want? Remove mutt. Real? What do you mean remove mutt? It is behind a reference. That's a lie. What? Session doesn't implement clone. So this clones brother. I need you to clone, my good man. What are you smoking? Instruction clone is not satisfied. I see. Where? You good? Is it saying... Bruh. That's just kind of cringe. Can you like clone the actual? Its trait bounds were not met. Real. Okay. No, it's right here. You goob. What do you mean its trait bounds were not met? G instruction clone. You lie. Okay. Alright, what do you want? Clone it. Does not clone. I literally said clone. I'm gonna kill. So, okay, so this needs to clone as well then. There you go, you freak. Okay. Holy. Okay. Crikey. Crikey. What about this? Yeah, okay, so now it does it. This doesn't need mutt, but you literally have next. My good fellow. Real? Don't you need mutt to mutt reference? Look at how little this is. Okay, so this loop is actually infinite. Boom, boom, boom. Because this doesn't die. If there's I guess I can actually literally just check. If state history is empty, then break, else undo. Holy. Holy. Oh. Okay, this is actually return none. There you go. All right. I like this. Sorry. So I want like this type function. Let me try that. G. Oh. Right. Alright, so this sucks. Frick. Oh, we're chilling. We don't need to clone this. Go next. Don't need this because we don't have a for loop. We're big chilling. If we can't undo, we're done. More moves. Nice. So if it goes in a loop, it just continues. Uh-oh. I guess it'll mega backtrack. This is pretty nice. But there's some caveats here. What do you want? CLI test. What are you smoking, boy? I see. It also added that back. Yeah, okay. Alright. So this is gonna still infinite loop. But it's like kind of better at it because it doesn't backtrack so much, or it doesn't like clone the state so much. It like automatically continues the iterator. Having a hash map of iterators is pretty neat. So, problem is the search space is very large. Yeah. 20,000! It's 20,000 moves in! Bro is 80,000 moves into the game. So I did the math, or I did the simulation rather, and winnable games are between about 92 moves to 192 moves. 94 was the lowest I saw. So 82,000 moves. I'm sorry, dude. You're probably not gonna win. But I could have better heuristics Weather simulator. I want to see like how much memory it's using. Card game. All right, go for it. Hello? I don't believe you. How is he using so little memory? Is that 29 kilobytes? How is he using so little memory? Oh, it's good. Look at this going down. Wait, what was that print? Whoa. Okay, well, that says to me, jeez. What? Where's the card game? There, Klondike CLI. Alright, bud. Okay. It's still not using that much memory. Why is it using... Is this 46 megabytes? Because it's the same color as this. Is this bytes or kilobytes? Like... I have no idea. I thought I was using 46 kilobytes and like 1 kilobyte of memory. Maybe it is megabytes. Yeah, it went up. I guess we'll see. It's 100,000 moves deep. So it's currently backtracking, and that's very slow because it has to run 100,000 moves. It's O(n) squared. You can see it's speeding up as the number of moves it has to do is... It's trying all the moves, observing all the states. It's cool. Yeah, I need stack undo. It just zooms up so high. We'll see if it goes to megabytes. I think it's megabytes, because like it would have to use that much. Wow. Fun. So what I can do is make it pick better moves. O(n) squared. No, it's just O(n). Zoop, 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 zoop. Did it reach next level? No, it's still at 89. I think that's megabytes. I'm interested to see how much faster it is with OF1 undo. There it is. Okay, so it is megabytes. All right, this is awesome. Yeah. So O of N undo is fine for like 100 moves. Less fine for more. Okay, so history. I think it's gonna need to be snapshots of the state. Which also means I don't need the seed. Indeed, seed. And then history. So then we'll have history snapshot. Yeah. State G. Instruction. There you go, bud. And then this is state snapshot. Indie brother. G. And that's GG. Game. Why is this eCache? I don't think we need that. Just go away. We really don't need like what I actually want is a 2-in-1 vec, like column vec, which I made a library for. History. You know, I guess it's okay, because you can always just access the element. So it'd be like state snapshot G, and then we can import this. We actually don't need clone on this sucker or any of that. I mean, it's kind of nice, I guess. So now we need this crap. Public function const state self G self dot state. No. I hate it when I smash a hotkey and I lose my place. That sucks. Oh, hoops. Reference. Instruction. G. Instruction. Instruction. There you go, man. Okay, so now the history is accessible, and then undo is a shrimple pop. I mean, it's that's I think that's strictly better. Snake snapshot. Okay, so hey man, so now I can make the undo implementation better. So where do we look at this? Self.state equals self.history pop type situation, and then none of that. Done. Hi. What do you want? Session state real. Yeah. State equals boom. State equals snapshot at state. Semicolon. And that's how it is. And what do you want? What do you want? True. That's so true. Absolutely true. So then we do snapshot. State is self state clone. And then instruction is that. Boom. Boom. Okay, history push. You've seen it here first, folks. Okay, so this is no longer replay the entire game history. This is just pop the most recent history off the VEC. And that is way faster. O of 1 undo. There you go, bud. Alright, let's see how it does. So we're going to look for Klondike. Alright. Oh no. No. State snapshot is winnable. No debug on that MF. Alright. Yeah, okay. Clone debug. Frick. Trade. Come on, dude. So annoying. Yeah, I guess I'll just put this on the game trade itself, cause jeez. Clone debug. Everybody does clone debug, cause screw not having that. And then now we're G on all this. It's implied. Stats clone default. Yeah. Stats default This is implied. You good? Alright, we got implied clone debug. Game implies clone debug for associated types. What was the actual thing that I did? Right. Minus 30 lines of code. Poggers. Alright. Run the track. Running. Oh, we immediately shot up to oh. Oh yeah, we're zooming compared to before. It is testing many more states. Woo! Woo! Zooming. It's now using a gigabyte, whereas it struggled to reach like 100 megabytes before. It's zooming. Alright, now we need to like... Alright. I'm thinking this. Except... that len mod 1000 equals 0. Then print it. So I'll go 1,000 at a time. To intensive card game real. Wow! It's searching. It's looking through those moves. It's gonna find all the moves. It can't find all the moves. There's too many moves. Yeah. Really? I wonder if I could do a modular arithmetic sort of deal. Where like I guess you could just like not hash the stock. Well, no, you need to hash you need to like unordered hash the cards in the stock. You don't really care about the you just care which cards are in the stock, not like the current position of the stock. I wonder. Well, that's a multiplication factor for sure. 5 gigabytes of memory. It's scanning all possible moves, but the move planning sucks. It's like moving cards back and forth really aggressively. I do have like a move priority thing. Wait, it's constantly like at 1,000. Oh, it's doing a big memory allocation. Mem copy. Oh my god. Okay, so it's still dipping into 100,000. It's so quick with it. Oh my god, I love my new implementation. Hell yeah. Is winnable. You have a hash map of game state to iterator over moves. So that's all possible moves starting at that state. And the first thing it does is populate the possible moves for that state if they're not already in the hash map. So if you do a move and let's say you like rotate the stock fully, you're back to where you started. So you've already exhausted that move, and so it tries the next move when it gets to that state again. But it's really simple code. Or it undoes, right? If there's no more moves, it undoes. What? What? Huh? 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 Did I just exhaustively prove that the card game is unwinnable? Oh my god, my algorithm was better than I thought. I mean, it took 204 seconds. This is tractable? I'm reporting this to my friend. This is mind blowing. So 10 gigabytes. Let's do the math. Observed states state moves .len. I want to see how many states it went through. Let's change it to one. Let's change the test. 124. It found it. It won. And this is how you win. Oh. Is when, wait, bool. Session is when, wait. Oh, is winnable equals, oh, okay. This is so with a little bit of like modular arithmetic type situation. I could actually exhaustively prove that the card game. Okay, how many? Oh, it's a state snapshot, of course. I see. Um, uh, oh my god, bro. Win moves equals is winnable. For move, no, you can't use that. And win moves dot into iter. We can just do this. Line. Yoink. Ins dot instruction. Debug that sucker. Sure. Into iter. No, dude. Into iter. Enumerate. So we want move number I, and then game is winnable, else game is not winnable. Oh my god. Indeed. So yeah. Homely momely. Alright, let's run that again. Yeah. 20,000 moves. You could probably do better. Than 20,000 moves. How many states did it observe? This is fascinating. Okay, 20,000. Okay. Calm down. Stop it. Get some help. Oh, interesting. So it played 20,000 moves, but only observed 8,000 states. Huh. I can't believe I can exhaustively prove that the game is winnable. It's that kind of thing that's like exponential, and it should either be totally out, like the age of the universe, the number of atoms in the universe amount to like it just takes infinite time, or it's like instant. There's usually no in between. Usually problems aren't this like barely tractable. That's so interesting. So if I'm just a little bit smarter about it, I bet you I can make it calculate in seconds or even less than a second. Oh, that's super fun. I also would like. My God, dude. Okay, 125. Go. We're playing a million moves? Oh, hell nah. I wonder if there are differences in the games that it's playing. And like some games have more moves and some games have less moves. It's so interesting. Wow, how's it playing 40 million moves? 4 million. that's the Rust message saying like, "Hey man, this test has been running for like a minute now. Do you want to like stop the test?" No. No. We reached 10 million card moves in one game. Ah. You know what probably happened is the card game is like a short card game that like um soft locks you very fast. So like you move a few cards and then it just and it you just can't make any more progress. That's probably what happened for game number 1, 2, 3. And that would explain why this has 19 million moves. Because this game you can actually make progress. I wonder if it's making progress. I don't know. It's using memory. 20 gigabytes. We never got to 30 million moves before. Oh yeah. Maybe it's like moving around the aces in the foundations. It's gonna hit 40 gigabytes. And my computer's gonna brick. Oh, it went back down. It's trying all the moves. Whoa. Look at it trying all the moves. It's so cool and fast. You'll love to see it. So it's walking back up. It's finding a couple new states. I can't believe how tractable this is. It went up to 30 million. I'm so curious to see how many states it spits out. If it's gonna actually like, um, uh, exhaustively prove that the game is unbeatable again. That was nuts. I can't believe it can prove the game is unbeatable. This is probably closer to a real game. I think what I want to do is make the undo find. Oh, I could actually keep the index in the hash table because it will never change. Oh, uh-oh, we're going up to 40 gigabytes. Everyone, hold on. Here we go. We're dumping into swap. It's still going. This little maneuver is going to cost us. Cool. We are at 40 million moves. Golly. I wonder how many moves per second it's running. Let's see. It was like 10,000 games in 2.3 seconds. And there was 250 moves per game. 10,000 times 250. 250,000. 2.5 million. But then divided by 2.3. So it's about 1 million moves per second. Cool. Oh, look at it go down. So we exhaustively searched through another branch. Oh. It's staying low? Is it going to find another card game? Look at that, how it like backtracks constantly. It's so interesting. The computational complexity of the game, or not the computational complexity, the combinatorial complexity of the game seems like it should be intractable, like chess. But I think there's a sort of like modular arithmetic you can do where like this card on here is similar to that card on there. Ah, look at it go down. Is it going to prove it? 1 million moves per second is pretty fast. Also, this is like incredible for like CPU cache because the entire game state is 336 bytes. So that it is in the cache like very often. So the CPU can absolutely go to town, which is why it can reach 1 million moves per second. What's my prediction for how many game states there'll be? I think it'll be in the 10 millions. Look at it go. so interesting. Watch it go up and down a million moves at a time. I think I'm gonna run out of memory. So I think card game 1, 2, 3 was like a short one, and I just got lucky. And now the combinatorial complexity is intractable because this is a longer game. You know what? Why don't we play game 1, 2, 3? All right. Yeah. See, it's already stuck here. So it proved that this game is impossible. So after like 77 moves, it got stuck. I think that's what happened. And then what about game number 1, 2, 4? Probably it goes farther. Oh. There must be like little paths through the jungle. As it explores the possibilities at a million moves per second. Oh man, how do you make it go fast? You just make the state really small. And then it never cache misses. I'm gonna put my coffee away. Let me know if my computer crashes. Because the memory gets full. You were supposed to tell me. You were supposed to tell me. Oh, it's sitting there trying to double the memory. Okay, let's run game number 1, 2, 3. I want to see how many moves it observes. So what was that? It was 204 seconds to prove that the game is unwinnable, which is 3 minutes in 20 seconds. Okay. So this one only goes up to like a million history. Oh, I see. This is reusing states better. So the other one was pushing and popping history, and the iterator state was on the history stack. But this, the history is in a hash map of state, and the iterator is fully consumed. It's persistent. It doesn't just restart. Okay, I see why this is better than before. My idea worked. Okay, what's my guess? Less than 1 million, like 800,000 states. I think we'll observe 800,000 states. something like that. That's my guess. Look at it, under 1,000. So here's the allocation, and then it keeps going. So it never uses more than 10 gigabytes, as far as I'm aware. History stays under 1,000. It's exploring all the games. Oh, and it'd be fun is to print out the actual game state. Oh my god, that'd be so cool. Display game state in terminal. Oh my god. Go for it, bro. Come on, hasn't it been 3 minutes at this point? I made my guess. Oh yeah. Wait, where's the observed states? I put the print in the wrong location. Okay, I wanted to see another thing actually. Right. Right. We could actually print the observed states alongside the history. Baba Booey. Uh, 10,000. Well, right. So instead of that, we could do I equals 0, and then I. There you go. There you go, bud. So every 10,000 moves, print. Go for it. Cool. It's kind of hard to read because of the, well. Allocate, 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 allocate. Go, card game, observe. How am I doing? Oh, my prediction was wrong. It's already at 1 point something million states. 800,000. It's not it. Looks like I was within 2 ballparks though. 2 orders of magnitude. Still a bad guess. $3 million states. This is how many moves it's done. 54 million moves. It's so fast. It now is using 5 gigabytes of RAM on calculating card games. Klondike. It's gonna do it. It takes 3 minutes and 20 seconds to prove that the game cannot be beaten. This specific game. It's like a seeded pseudo-random number generator. And like the only randomness is shuffling the deck at the beginning of the game. $100 million moves. How do we get those numbers down? Right, okay. So when hashing, I can make a custom hash function for the game state. Oh, we're going up to 10 gigs of RAM. One card game is 336 bytes. So 10 gigabytes. Well, yeah, here's the number of observed states. And then history is how many moves deep into the game it is. It spares no expense. There are no filtered moves. So like moving aces between foundation slots of Klondike, which I could show you. So like going like this, it goes like this. There's no expenses spared. And of course, cycling the stock as well. It treats each state differently. Whereas, it observed 11 million states. Game is not winnable. That's insane that it ends the game. The longer the game goes on, it should be fully tractable though. Cause like, well, I don't know. Cause like, this is what this proves is that short games are tractable. But that doesn't say anything about long games. For games that you could win with the auto move, it went from 94 moves minimum. That was the shortest game to 192 moves maximum. So that's like the combinatorial complexity squared. Should I? I guess not. Yeah, no, this is exploring all states. Ooh, nice song. So the history is really long because it keeps spinning the stock every time, and it doesn't like go back in the history when it does that. So the history includes duplicate states. It can like reach the same state. Oh my god, what would a graph look like with if I could visualize that, that would probably give some insight into the game. It would probably look like a big diamond, where like it's a grid where you can move this card over here and then move this card over here, and that forms like a historic path. So if you do this card move and then this card move, it's the same as if you did this card move and then this card move. So the state goes like this and this, or like this and this, but it ends up the same. if I had like a theory of non interfering moves, then I could count more states as equal. That's kind of like exploring triangular numbers rather than exploring all combinations of numbers. Is that higher dimensional though? Yes. So it gets better with the more the larger the number of non-interfering moves are. So what would be a non-interfering move? Well, this is a non-interfering move. So like doing this and doing this. Like, okay, so this is always accessible. Oh, it's different in Draw 3, though. I wonder if that's... would be faster. Probably would be faster. Let me try it. Let's try it. Let's run Is Winnable on a different game configuration. Excuse me, sir. Okay, so let config equals to kconfig kernel configuration. So then draw stock like that, and then new not default, give me the config. Why don't I put this in a goddamn variable? Okay, so if you draw 3, do you visit fewer states? Does the game end faster? Probably. I bet you there's like a third the number of states. And it takes a third amount of the time. So like a minute rather than 3 minutes. This is so cool. It's kind of like stars aligned. Yeah. Look. Oh, wow. There's a lot fewer states. $20 million moves. History is way shorter. Was that in one screen? It was. So it went kind of deep. Yeah, so if I hash if I don't count, but it's not really true. How to prune the branches. Okay, this just got interesting. Should we try game 1, 2, 5? I wonder if 1, 2, 4 is winnable. Let's see. Zoink is winnable. 9. How many moves with XD moves? Win moves, Len. Do it again. Probably you don't need to do that many moves. Oh, I just invented an algorithm. How do you say the actual number of moves? You match states within the history. You search from the beginning and the end until you find the first matching state. And that's your thingy. Is it just one? Is it always just one matching state? What if there's a matching state here to here and here to here? You'd have to like find both and collapse the shortest. Wait, I guess that counts as like the first matching state. Probably is like 100 moves. In reality, I can't think of how to make the histories shorter without leaving paths unexplored. Gosh. Non-interfering moves. That would drastically reduce the combinatorial complexity, but I can't really wrap my head around it. That's 124, right? Let's try. Oh, this is 124. It went into 4, 5, 6 hearts. A. Okay, so card game number 125 ended up using too much RAM. Yeah, I don't actually know the real number of moves. Match. I guess you go like this. First one, look from the back. Second one, look from the back. Third one, look from the back. And you just like loop through all of them until you find the longest one. I guess there can be multiple. Your blur is raiding with a party of 4. Hello. I am winning at card games. I made a command line card game, and I'm winning. I'm trying to make an algorithm to win, to like, is this game winnable from where you are? Ugh. How was your stream? Isn't this algorithm nice? It's nice. World record on surf. You streaming surf? Cool. Nice. We can actually see it. How do you... Oh, it's 5 men. That's not surf. Did you change your username? Oh. All. Sideways. Of course. Doesn't say style. Well, by process of elimination... I don't get name changes. Why do it? Map is so terrible. Are you talking about the Z fighting? Using different names on different platforms then. That's a bit different though. I do understand that because like sometimes names are taken. Nice. What was that? What was that? Boing. What? is there a little booster there or something? That's the ramp. Okay. Oh my god. If I actually put this together, the game can detect when you soft lock yourself, when you like trap yourself before you reach the bottom of the trap. So like imagine you're playing the game, you're like, "Oh, I'm playing the game." Oh, and then like you do this move, it's like, "Ah, oh, you lost." You're like, "What? What? What? I still have cards here. What?" But it's because that one move holds back the whole game eventually, or something like that. And there's no longer a path to freedom, and you must undo. I could do that. That could be the Klondike future. The code would need to get much more complicated than this. This is so cool. So cool. It is so cool. It only ran 1 million moves. Wait. 980,000. What's the iteration order here? Let's look at the iteration order. Klondike instruction. Klondike instruction. Okay, so this is how it works. I am an iterator. Next. So it starts at so this is a Klondike move. So this is the game board. So these are tableaus, these are foundations, and this is the stock. So what can you do? You can rotate the stock. You can move a card into a foundation. So destination foundation. So like into there, or destination tableau. So that would be a move like, I don't have any moves like this. But you can also move stacks. So when your destination is a foundation, the moves are different. You're allowed to move a stack. There's no other situation where you're allowed to move a stack. So destination tableau has this pile stack, whereas destination foundation only has a pile because you're only allowed to move one card into the foundations. Streaming serve and B-Hop is really fun. Wish there'd be something for it on the Discord. Couldn't you like stream to Twitch and to Discord and just like hang out in one of the channels? The Z fighting doesn't exist on that. Well, yeah, that's my Strafe client renderer. So what this does is it starts on the first foundation. Help. So Tableau 1, Foundation 1. It's like you're moving a card from Tableau 1 to Foundation 1. That's where it starts. So that is this move. Boom. This is Tableau 1 to Foundation 1. Tableau 1 to Foundation 2. Tableau 1 to Foundation 3. So that's how it starts moving is when you ask what the next move to look at is, it goes like, oh, are we on foundation moves? Well, what's the next one of those? All right. And then destination foundation has its own little next function. It begins at Tableau Foundation 1. And then it goes like, all right, what's the next source? Oh, it goes like that. Okay, so this is iterating moves like this. 10 million moves per second with that? Oh my god. It's literally just going that's literally what it's doing. And then the next one. It just tries every possible move every single time. Could it be a little bit smarter, maybe? I have bad experience with VC on Discord while streaming. I understand. That's not gonna help. Oh no, I'm playing cards. Okay, yes, so it has this thing that goes over all possible moves. And all it does is it filters out moves that are invalid. So like filter useless. Possible. Indeed. So this goes like all moves, filter out invalid moves. So it is looking at every single move, but it's just filtering out the invalid ones. Could a streamer role be a possibility to exist? Anything is possible. I don't really manage the Discord. The Discord is managed by the Discord staff. You'd be better off talking to them about it. So I kind of want to call this function get sorted moves. It's also kind of not nice though, because it allocates. That would probably slow down the number of moves per second by like 5x. I don't know, maybe 2x, I don't know. So So we would go from 1 million moves per second to like 100,000 moves per second. That's like 10x. I have no idea, but it will for sure make it slower. It will filter out useless moves, but the number of useless moves you can make is pretty low. What should I say? The same thing you said to me. I mean, have you tried before? Four bytes. For the boys. Klondike Itter. So this one is 4 bytes. This is also 4 bytes, which is very cool. For the boys. God, I love this. 1 million moves a second. That was pretty fast. Could probably be faster too. How much smaller could I make the state? So the state is using these array vecs from Mr. Stack here. So this guy is using a U size. Oh, length is U32. I was wrong. Oh. Is there like a crate feature for using like a U8 as the length? Oh. Oh, hell no. What's this? Dude, if there's a crate feature, why is this different? Opened a ticket. I want this to be U8. It's gonna be smaller. I wonder if well, let's see. This should not be a feature. People want it. I want it. Oh, yeah, no, that'd be good. Land and no longer constant. Yeah. After 255. Yeah. I'm really interested in this. Uh, yeah, dude. Hmm. Well, it's because of const generics or const traits rather. Oh my god, bro. So it's just like not a complete win. It would make the it would make it smaller though. Come on, man. I think it would make it like 20 or 30 bytes smaller. Well, there's a lot of these, so like, oh my god, bro. What if there's a crate for it? Rust. Help crates. Array vec. Oh. Huh? Generic array, my brother. Fast vec. Const. That's dumb. Okay, let's just interrupt. This is literally just arrayvec. Oh. T. Len. Wait. Where is it? C. Wait, there's no U8? Nor. Oh my god, bro. This should not be a feature. But that would work in current Rust. We wouldn't need anything special. It would just be like 2 lines of code. Updated to yield. Blunderbuss. Well, I mean, if it hasn't been updated in 2 years, maybe I fork it. When in doubt, fork it. Not really a good idea, but fork it. Okay, well, Oh my god, bro. Like, supersedes bada bing, bada boom. Like, look, it's like 30 lines of code. Like, bruh. What the hell is that? Go away. Don't do that. Don't do it. How come? Yeah. Huh? Why? Sir. I see. So some of the things were failing because number too big. It's such a simple feature. And then they can change it to generics once Rust has constraints. Make it work now. Oh my god, bro. What is the difference here? Why is there not a const? Huh? It's kind of goofy. What? Make maybe uninit, bruh. Const function new. So new was const, and now it's not. Ah. You need the new const function. What the hell are? New. Why is there a difference? Is this compile? Why is it not const? Who did this? New. New. Who did this? Blame. Why? New function is significantly faster. It optimizes better at the moment in current Rust. And then they didn't explain that in the code. Years ago. When was the most recent comment? GitHub? GitHub is broken. Great. 2 weeks ago. Really? And there hasn't been a release in 2 years. Oh, interesting. We're so back. Maybe it'll get the feature. That'd be neat. Maybe I should comment, be like, add this feature. It works. Break it later. Yeah, just break 400,000 users. Easy. So easy. All right. What am I doing? Right. I wanted to come up with a better algorithm, but I couldn't wrap my head around it. So the computational complexity is just out of reach. The combinatorical complexity is just out of reach for exhaustively proving that the game is not winnable. In the winnable games are going through 133,000 states, which is somewhat quick. Zoink. 1 second for a million moves. That is damn fast. That means that each move uses less than 1,000 instructions, approximate. That's not true, but in that ballpark, I'm guessing. Because like you can have more than one instruction per clock cycle. Homely momely. I wonder what the hottest code is. It's probably the iterator. I made the whole thing const, which is neato. I wonder if an array of all possible moves would be faster. Probably not, because then it would be memory bottlenecked. Whereas it can just generate the array using 4 bytes. And it just stays in its hot path instead of needing to read from memory. Because that array would be like several thousand things long. 1,000. Is it 1,000? I don't know. Let's see. Let's do it. Here it is. Here it is. How many possible moves are there? Assert equal. Oh, haha. Give me the iterator. Hi. K iter new dot count. It's equal to 1,000. I'm gonna guess 7 times 4. It's like 250 moves. All right. Test how long? 721. So it's going through 721 moves. Every move, it looks through 721 moves. How is it that fast? I'm thinking about like the CPU hardware. Like, yes, it can run more than 1 instruction per clock cycle, but that's not like more than like 4, right? So my CPU is 5 gigahertz. Oh, 5 gigahertz. Okay. So So you have this function, is instruction valid? That's somewhat small. This probably compiles decent. Top card. Okay, I mean it's in the ballpark. I see. 5,000. I was thinking 1,000. $5 billion clock cycles per second. 1 million Klondike moves per second. So it checks every possible move, and it's still running up 1 million moves per second. Yeah. Is there a way to make it faster, or like? So I would need to approach it from all avenues. I would need to make the the order with which it checks moves better. So it checks better moves first. I would need to make the speed that it can calculate possible moves faster, and I would need the most important part would be to algorithmically improve the winnable functions. So this is like really clean code here. Oh my god. I think I want to save this test, actually. We're going to leave the config on... Actually, I mean, maybe I just leave it like that. Oh, no. Oh my god. Delete infinite loop test. XD. That's right. This is informative. It's cool. That's cool. All right, then I go like bop, And now we can see the beauty of the function. Wow. Wow. Is win. Max win. So it constructs, or it fetches an iterator from a hash map. So this is it is states that it has observed before, and it's calculated moves before as well. So G is the game state, and then this is an iterator over moves that's partially iterated already. So it grabs the iterator for that state, or it creates a new iterator for that state. Then it grabs the next move, and then it runs that move next, and then it goes and checks if it won. But if there is no next move, then it undoes. But if you can't undo because the history is empty, then you're done and you can't win. It's unwinnable. You've exhaustively proved that it's unwinnable. So yeah, the iteration order of this really helps it get deep fast. So a problem with this is that it's constantly rotating the stock to and that's like, so like does a move, rotates the stock 24 times. Does a move, rotates the stock 24 times. Which results in this 1 million moves to win a game, where it's just like moving cards around that's totally useless. And then it keeps it in the game history. It's like, it took me 1 million moves to win the game. Whereas most games are like 100 moves long. But if I truncated the history, because what that means is that you kept doing moves, and now you have a duplicate item in the history. So if I just truncate the history back to that duplicate thing, now we've lost all of the in-between histories that were generated from that move that we'll never try again, because we have this iterator over all possible moves that has already had the move tried. Next move. So we're throwing away those paths without trying the moves when we truncate the history. So the whale song. Why don't I fix it up right here? History includes cycles. So uh-oh. No, that's always true. God, what's the best? Okay, so it's about 1,000,000. It's not that bad. We'll just like go and whatever, man. Oh, you know what I can do is actually collect it. I believe. Help. Okay, so it goes like this. Nah. Wee. All the way home. State dot dot iter dot map. No. Enumerate dot map snapshot. Snapshot help snapshot dot state I collect. Oh hell nah. Does that do the first one or the second one? So reference to G, I guess that's smaller. It's good. I don't know if it's doing the first one or the second one, because like, what if there's multiple states? Does it have the smallest index, or does it have the most recent index, the largest index? I don't know. Why don't I test it? Rust sandbox. Box. I'm a boss. Alright, shut up. Okay. Here, give me that. Yoink. Oi. Alright, we got a thing that goes. Okay. State equals to A, B, A. They're smart, you see? Okay, and then at the end, state index, debug him, question mark, semicolon, gabagoo. No. No. Oh, no. Is that always true? Okay, so that's still okay. So that just means that I flipped the algorithm around. I would have guessed it was the other way around. I suppose this makes sense, though, because then you can just do insert instead of check it's already there, then insert. I think that makes sense. Yeah, okay. So now the state index contains the indices of the farthest dinguses in the table. Wow. And then we go Mutt. While at some long equals to state index iter is this state index? Oh, I wonder why I called it state index. So this is the GG. Are you good? Are you good? And then this is the reference. No. Filter map. This is wrong. This is wrong. I did it wrong. State.history iter enumerate. Filter map. Index state. Filter. And then snapshot, I guess. In dot get dot help snapshot dot state and then minus question mark minus do you believe in God? Question mark minus. I was thinking of Renegade Angel. Okay, so then last index furthest towards the end, whatever. It's something. Option U size. Question mark semicolon. Uh-oh. For real? And then so now we have some kind of index thingy. No way. So this is the current index of the history item. This is the index of the farthest along history item with the same state. So we go let longness equals boom minus boom. Longness not equal 0. Then some. Snapshot. Snap. Is that real? It's the long. I am the long. No. No. Oh, it goes me to you actually. So it goes like, "Hey, buddy. Hi. Yeah, dude. What do you want? Filter map. Oh, dot. Oh. Yeah. Min by key range.len. Hello. What do you want? Expected dingus found dongus. Not real. Oh, wait. Expected filter map found option. What did I write? What this doing? If I write panic, does it help? No. Help. Okay, so, hey man. Min by key. Oh, is this inside the... Oh. Wait, what? Oh, whoops. It's here. There we go. Have a good day. Goodbye. Okay, so now I have long. So remove range, we can call it. Longest range. Find the longest range where the start and end are the same state. So if they're the same state, delete it. It doesn't need to be part of the history. So then... Oh no, it's holding it. Oh no. Alright, we can just clone it. Then we don't need to have any bustling about it. Alright, so then yeah. Okay, so now what we need to do is update the state index. Should we just recompute it? Does that make the most sense? Because, like, what if there's other ones? There's not. There's not. There's provably not, because it found the farthest two. And if we're removing those ones... But what about the not related ones? Does it say anything? So they might be out of the range. Like this one is over here and that one's over here. It might just be a smaller range. If the start is in the range, then no big. Oh, I can just do it. Just do it. Okay. Let's try it. State dot drain. Yeah. Semicolon. Just get rid of it. Bye bye. Can it do? Is there like a operation to just do this, or is this just GG? Whatever. Okay. So I have removed the longest range where the start and end are the same state. So if you do a bunch of moves and then you get back to where you started, you may as well not have done any of those moves. So we're just going to delete them from the history. But now we need to recalculate the state index, which is it. So we go like, 4. Help. It's this. Help. Oh. Help. Uh. Uh. Index. It. We need to clear it actually. Clear. Because you can't leave. Wait. Does that matter? No, it doesn't. Because so there will be some dangling states, but they don't exist anymore, so it'll never find them with get. What do you want? Oh. Long time. Okay, yeah. So once there are no more non-zero ranges, we have collapsed all of them. I don't know if this is the right algorithm, but it is. Let's run it. Let's run it. Run the track is winnable. Okay, it shouldn't take that long. It should not take that long. Is this on 123? Help. 124. That's winnable, bro. Bro. Maybe my algorithm is bad. Let's look at the computational complexity. Okay, so this is O of n. O of n. O of n. O of n. So it's just O of 1 million. Is it trolling me? One. Oh my god. Okay, so what? Why is it not getting out of that? Min by key range dot len. Drain longest range. I made sure that it's not 0. So it's not trying to drain 0 length ranges. Okay, print time. Okay, history length. Drain len. Help. Is that gonna work? Can I do that? Real? Question mark? Real. Okay, go. 0, 0, 0, right? Wow. Okay. I see. So I just need to let it run. Okay. Well, it would appear. It mostly consists of non-intersecting ranges. I would like to see the range length. Do it again. Zoink. 2. What was the 2? What? Whoa. Oh, I freaking min. Oh my god, dude. Okay, maybe it'll. Yeah, okay. Yeah, okay. Okay. So it just forgot to delete the 7,000 long range first. Yeah. Okay. Okay. That makes a bit more sense. That was very surprising. Okay. So I don't actually. Okay, is it still the same? No, it's better. Okay, so it said 175 before because it was deleting the wrong ones. So this algorithm is better at showing you the moves. You got the move. That's the move. This is, yeah, that's what I was thinking. Is like you could like do it wrong. Okay. Well, there you go. Oh, I forgot. You can make it better. Drain longest range. Slice. No. Start. Yeah. Long time. So you only need to update after that. Now it's slightly faster. Oh, never mind. It's slightly wrong. Huh? Okay, I could actually I'm doing max, so it doesn't really matter if it's 0 because we're finding the biggest one. Yeah. So we don't care. Oh. I'm gonna say end index. I mean, I guess. What is card game? Library. I made. Card game. Check it out. Check it out. Whoa! It's a card game. And it plays itself. You could do like custom moves. Whoa. Tableau 5, move to foundation 1. So this ace of clubs moves here. Actually, let's go to foundation number 3. So it's going right here. There you go. And then 7 on 8. He won on a T2. So I made command line card game, but it's mainly as a card game library. I made this on Friday and Saturday and Sunday and Monday and Tuesday today. Yeah, I made this because my friend made a AI card game, but it's buggy because the AI isn't very smart. And I was like, well, if I just make it so that you can't misuse the library, then there won't be bugs. So I made it. Also because I thought it'd be fun to make. He hasn't integrated into his game yet. Alright, bro. Okay, why did this not work? We have history, except it has been drained. From dingity to dongity. That does not include the last one, so the start should always exist. What? Huh? Strafe client vacation. Yeah. If we drain the range, the element after the range goes to the start of the range. Removes the subslice. How can range end index? Range end index? Oh, it's this. Okay, I think I understand. Okay. Yeah, no, that's why. Okay. So it's updating the index of the state that's farthest into the list. So this is a hash map. So if it's the same state, it'll update it if it sees it again and set it to the farther index. And what happened was it removed some states, but then it thought, oh, I can get away with only I thought I can get away with only updating the ones after. But what if it deleted the rest of the list and there was a duplicate state in there? Well, now it thinks the state is over here because it didn't update it because it's only updating the list after. But now it's over here. So it was wrong. Clean history. There you go, bud. Yep. Game is winnable with 158 moves in 0.13 seconds. Let's try more games. Bop, bop. Come on, bro. Please. 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 Oh my god, bro. Alright. Shut up. Okay. Let me see it. Zoom. Alright, I'm just gonna print like compacting history. Dot dot dot. There you go, bud. So we only had to compute 50,000 moves, so it's pretty quick. So is it like that for all winnable games? Should I just give up? Fast. So let's run through it. So 124, we already looked at 125, 126. Ah. Too long. 127. Too long. 128. Too long. 129. We should see another one. That's so cool. 30. Just casually look at 10 million states. 131. Okay, so we're getting unlucky. Oh, no, it does happen. Okay, so we looked at 100,000 moves there. I'm wondering if I should just give up after a certain number of moves. So, like look through a million moves or something. But I mean that's a full second. The history compacting algorithm can probably be done better. I wonder if actually just searching is faster. No, because it's O(n) squared. Let's keep going. 132. Hell yeah, brother. 270,000 moves. That's right. That's right. There's also the 3 card game. I wonder if that one's always like easy winnable. Come on, bro. Go for it. So it's a totally different game. Is it? It should be the same game. I mean, it looks like it's not winnable, but it has less stock history, so it should be able to observe the states way faster. It'll, yeah. This type of game will be much less combinatorically complex. And if the normal games are like almost manageably combinatorically complex, then if you just like slightly reduce the combinatorical explosion, look, we're on like history 400. This is almost certainly gonna complete. Ugh. I just had a funny idea to like make the Klondike config be a struct generic. But you can't do that in stable rest. A generic, const generic, that's right. Silly boy. Oh, hey, wait, it is winnable. Whoa, that took a lot of searching, a lot of soul searching. That's really interesting. Okay, so this is the same game as the other one, except you can only move 3 cards at a time. I'm guessing it had to search longer because there's like a specific combination of the like modular cycle and like carefully picking out when each card is that leads you to the win. Cause yeah, 183 moves is a really long game. Ah, it's so cool. I can't. It's so cool how nearly tractable this is. Just one algorithmic breakthrough, and it'll be like, ah, 131. I think draw 3 is like a algorithmic breakthrough. It's kind of like an algorithmic breakthrough. Oh well, yeah. See, look at the difference. This one is diving headlong into the history. So probably this one is not possible. Keep an eye on the VRAM on the RAM. I don't know. I don't know. I wonder if I can make some kind of test that runs overnight that where I can complete lots of games or like exhaustively prove lots of games. Oh, but each one uses lots of memory. I don't have enough memory. The one game that I've exhaustively proved took 3 minutes to prove that the game is not winnable and 10 gigabytes of RAM. So cool. 152 million moves. I should have read my messages. Is it at 10 gigabytes yet? Yep. I think that the game that I proved, now make it GPU compute. That's not impossible with tools like Rust GPU. My the game is very stack friendly. Very stack friendly. The problem is this algorithm is very serial and requires a lot of memory. It requires recognizing states that have already been observed. I have no idea if this will complete in a few more minutes, a week, a year, the lifetime of the universe. It's really cool to like think about how exhaustive it's searching. It's literally searching every single possible move. And it actually exhaustively proved. We're going to 40 gig. We're in the swap. It looks like the swap is pretty efficient because it doesn't visit the revisit the states often. But you never know. You never know. Oof. Wait, it's 22 gigabytes. So yeah, the compute isn't really the bottleneck here. It's the memory. Um, I mean what if I designed it to be recursive instead of vec, instead of pushing and popping to a vec, so it just spawn a new thread. But that would work. Oh, you get like a thread pool. Yeah, that would be totally stack. That would work because like it will know. No. Because like observing the states. Yeah, no, any thread could encounter a state that's already been observed. Write the algorithm in pure assembly. This is fast enough for me. That's always linear speedups. What I need here is a paradigm shift. I need a algorithmic computational complexity speedup. Combinatorial complexity speedup is what I really need. I need to like identify parallel game paths that all lead to the same game state, and like be able to evaluate them independently as like vectors, kind of. Oh, are we getting close? The history, it's bopping up and down the history, very close to the bottom. Well, very close. It's bouncing off some sort of... It's really probing the iterators here. Hey! Let's go. I proved another game. I proved that another game is unwinnable. It only took... Wait, how close was this overflowing? I think this is an I-32. We were a quarter of the way to overflowing. Do it, bro. Yeah. Print. Well, yeah. Why did it print? Oh, because it's none. No, it is winnable. Wait, it won? Oh. Wait. Huh? That's not what I expected. I thought it proved that it wasn't possible. Proof. Proven. Proof complete. I like that. So it spent all that time, and then it proved that it was possible. Let's go to draw one and see if it's like instant. Yeah. Okay. What? I can't figure out an algorithm to like treat independent moves independently and like explore a local space. It really comes down to the game itself. God, this is so cool. I should print every 100K. I want to see another game proof that it's not winnable. Let's write them down. 124, 131. Wait. That's a short history. God, it's already so fast. So it's about 5,000. It's about 5,000 clock cycles per game instruction. Oh no, that's the rest thing. Okay. 5 gig. No, yeah, 5 gigs. What's the difference? Hey, wait, it's winnable. 132 winnable. Oh. Interesting. So it got stuck on early game. $131, $132. We're revving up. I don't really understand the space of what's happening. I don't really understand like what's the longest game to prove? What's the most possible states for this game? It's definitely exponential based on the number of possible moves. Oh, proof complete. Is it possible or is it not possible? That's a long history to compact. Uh-oh. Is winnable. Game is winnable. Crazy. That's the longest winnable game I've seen. $3 million observed states. So it exits as soon as it finds a win. Man, if I well, okay, so it can exhaustively prove that the game is not winnable, which means it evaluates every possible state. So I could also search for the shortest path to victory. Yeah, this only really needs one breakthrough, and then we can have a hint. Every state. I can't believe it's tractable. Wait. No. Well, yeah. What if you don't hash the foundations? Because all of the other cards imply the foundations. Oof. That's just a small linear speed up. It would remove shuffling the aces around. I don't think that's that many combinatorics though. Nah. I mean, it does add a multiplier when you have aces, but it's like 4 choose 1, 4 choose 2, 4 choose 3, 4 choose 4, which are all tiny numbers. Okay, I could have actually just thought about it for 1 second. So, yeah, there's 6. The biggest multiplier to the combinatorics is 6. So, removing the useless moves of like moving the ace, doing this, 1, 2, 3. Like, yeah. The biggest one is 4 choose 2. So when you have 2 aces, oh my god, bro. Real dude. Really, dude. When you have 2 aces, you have 6 ways of arranging them. Oh, that's not true. Because it does actually count the other way around. Three, 3, 3, 3. It's 4 times 3. $12. Oh, you can't actually. Well, you might be able to. Yeah, but it's always. I don't know. It would definitely help by like a. It would divide by a constant number, which it's not really a like a paradigm shift, but it's a constant speed up. It's a linear term. If I can find multiple linear terms to speed it up, then we're schmoving. Okay. I could like add a is useless move type situation. Why don't I just kind of explore here? Whoa! Yo, what do you think of vibe coding using AI instead of fully coding from scratch? Do what you want. I don't like it. I want to learn and think. That's what I'm here for. And so if I outsource my thinking, I'm literally just not doing what I want to do. Most people are programming to try to make money or something like that. And I'm not doing that. Okay, I'm going to make a freaky deaky trait here. I actually started this project. This is an AI game written by my friend. Well, written by AI, controlled by my friend. And it's buggy. Like, you can't do this move. And, like, it randomly thinks that you locked up your game when you didn't. There's obvious moves. So it inspired me to like, write a card game library for fun. So like I can go move this is stock in my hand. So this is like the stock right here, and then like dealing a card is this move from stock to stock. So now my hand has this card. I can't play that. Go again. Oh, 2. Stock into foundation 2, which is right here. Cool. Stock into foundation 2 again. Cool. Jack onto queen. Stock into tableau 1. 10. Can't do that. Oh, tableau 5, tableau 6. So, this, as far as I know, this is bug free. It will not let you do any invalid moves. it's able to iterate over all possible moves, and it knows when the game is won. What I'm currently working on is a like is winnable to try to detect if you can win the game. The problem is it uses 20 gigabytes of memory and takes 5 minutes to calculate. And that's in the best case, and I'm not really sure if the bad cases are worse. So I need a paradigm shift. I need an algorithmic improvement over this. Look at this nice small algorithm. Did I win? And then it makes an iterator over all possible instructions, puts it into a hash map according to that specific state. So if I am in this state, these are the possible moves. And what it can do is it can turn the iterator and get the next move, next move, next move, next move. And it remembers the moves it's already done. And they don't show up again. So it just runs one move, boom, next, boom. And then we start again. Did I win? What are the moves? Run a move. Boom. Did I win? What are the moves? Run a move. Boom. And if there are no moves left, then it undoes. Wouldn't that make like thousands of combinations, causing a memory leak? What are you talking about? 124. In this case, it finds the win very quickly. But if we go to game number 123, give me the numbers. Bob, come on, please. If we go to game number 123, run. So it's just on 1 million moves. It's just on 4 million moves. And it has observed 500,000 game states. We can watch the memory usage grow. It's currently using 1 gigabyte of memory. For this specific game, you can see that the history, that's how many moves into the how many moves it's done since the beginning of the game. And it's doing things like fully rolling over the stock. So it's going like this. Right? So that's why there's like 10,000 moves in history. Is because it like does one move. So like, let's see. 2, 5. Help. So it goes like this, and then it goes like. So it does one move and then rolls the stock, and then one move and then rolls the stock. But I claim that it will actually prove that this game is unwinnable. It will exhaustively search every single game state, even the ones that are dumb, like moving these cards around when they're just aces. It takes 3 minutes and 20 seconds. Oh, we're allocating memory. Memory usage going up, 10 gigabytes. It ends at 10 gigabytes. It doesn't go to 20 gigabytes. It has to mem copy the hash map into a larger allocation. Doubling size of hash map. 1.5 billion moves. No, oh, it's 153 million. Excuse me, 153 million moves. It's so cool. On the games, on some of the other games, the history goes up to the millions. Hey! Game is not winnable. Oh, dang. All I had to do was look through 700 bajillion moves. Ah, man. So it saw 11 million unique games, but that is every game. That's every state that you can reach from that beginning of the game, which is not combinatorically intractable. Like it's not the number of atoms in the universe type of number. It's like 11 million, which computers are great at doing 11 million. So it made 178 million moves, but it only saw 11 million different states, different game states. Oh, well, this many. So the like combinatorical explosion is pretty kept in check for Klondike. At least for this short game. I wonder what the longest move chain is. The problem is that it takes a while to calculate to like compact the move chains, because like let's say it goes like this. It doesn't then jump back into history to before it did that. It knows that it has seen this game state before, but it includes all those moves in history. So when you win, if the game wins, which it does on game number 124, 124. So on this one, the game does win, but it's played 20,000 moves. But what it does is it recognizes game states that are the same state, and it just goes, oh, all those moves in between it, just delete them, because it's the same game state. So you may as well have not done those moves. So it takes the 20,000 move chain and it compacts to 158 moves. And I did a simulation. Help. Bench right here. Klondike bench. CD bench. Cargo run. I forget what it even does. Yeah, okay. So this just played 1,000 games. Not moves, games, full games. And it kept track of how many moves it made. So this is a 0 move game win. Yeah, it didn't get any of those. So the least number of moves is 94 to win the game in terms of observed empirical evidence here. I think that it's 52 plus 24 is the least number of moves. So like if I start a new game and I just go like boom and like I just send each card in, I'm the luckiest player alive. I don't have to do any moves like this. All of them go directly in. I still have to cycle the stock over and then move this in. So there's 24 items in the stock. So 52 plus 24 should be the least number of moves. So 76 moves is the luckiest game you can get. So the minimum number of moves is 76. Oh, interesting. In 3-card Klondike, the minimum number of moves is 52 plus 8? Because one stock click reveals 3 cards. Cool. Well, that's pretty cool. Let me actually go simulate that. Do it again. Aha. So draw 3 win rate is 6%. Oh, brutal. Did it get lower though? Did it get lower? Well, let's do 10,000 games because like 1,000 games is like. All right, this will run for like 20 seconds. You deleted the duplicates. Did you try to load the seed 1 to 3 manually to see if anything looks odd within the card placement? Yes, I have done that. We can do that. Number 123. This is the game. So we can play around T2, T3. Stock. Queen, king, ace. Nice. King, king, ace. Nice. King 3 goes on to 4, but we could just kind of keep going. 7. There are moves I could make, but they don't further. Okay, is there any 7s? No. There's a 7. Ace. So I mean, I'm pretty sure I proved that the game is impossible. All right, that's finished. This is what was that? 100,000 games, 10,000 games. Okay, only 10,000. Let's take the moves tally. Ooh, and see how many moves it is. So we make a bar chart of the moves. That's the move. Ah, we don't have enough samples. Okay, so one of these is huge. 39. So let's see how many that is. Length. Keeping in mind that the first one is 0 moves. So the length of this is 105. So that would be 104 moves on average for 3-card Klondike. I think it was 122 moves on average for 1-card Klondike. Draw 1. So you do quite a bit fewer moves median. They might the center mass might be closer to here though. Let's just run this with 100,000 while I'm waiting, or while I'm looking at this. Okay. So what's the biggest amount of moves? We can actually say -1. 144 move maximum. It was 192 for the other one. All right. What about this one? How many moves is this? This is the shortest amount of moves to win the game. That looks like 80. Holy. 86 moves to win the game. And the minimum should be 52 plus 8. Or I let 24 divided by 3, which is 8. 60 moves minimum. It should generate a winnable game with any seed. In theory, if the game is mathematically unwinnable with all the possible combinations of legal moves, it might be the algorithm's fault in creating an unwinnable game with the X seed. Algorithm's fault. Oh, you know what I could do is I could play the game backwards. Oh, that's kind of cool. To generate a winnable game. So you don't need to test if the game is winnable. You just generate it backwards so that it's always winnable. You just play backwards. That's a good idea. Because like one thing you could do is like generate a random game, see if it's winnable. Generate a random game, see if it's winnable. But that's clearly slow with the current algorithm that I have. I'll show you the deal algorithm. Oh, it's in here. Help. Here it is. So new Klondike with seed. So it creates a random number generator with that seed, and then it calls this function. Okay. So this creates a full deck. What's that function? For every suit, for every rank, and rank is like ace, 2, 3, 4. Suit is obviously this. It just creates every card. Okay, full deck. Amazing. So we have a full deck. We shuffle the deck. Just very simple. And then now we have this thing that gives us cards. It's an iterator. Every time we call next card, it gives us a new card. And it's shuffled. So generate tableaus. So this is calling the pile function. These nuts is the number of face down cards in the pile. Down. So this one has 0 face down cards. So it takes 0 cards from the deck and puts them face down. And then takes 1 more card and puts it face up. This could be better named. So then number 2 has 1 face down card. So it takes 1 face down card, 1 more face up. Okay, well, you see the pattern. And then this is the remaining cards. Are we writing blackjack? I made a card game library, so it would be possible to write other card games. I just have Klondike right now. I'm interested. It's really efficient. I can. Oh, it's running 100,000. It's still running 100,000 games. Let's see. It should take 200 seconds, which is 3 minutes. Release Stake 2. Is that a card game? I don't know card games. I'm assuming that's like an online famous cards thingy. Cool. So that's how it's generated. It just shuffles the deck and puts the cards into place in order. Big gambling site. I have never heard of it. That probably tells you a lot about me. What was I saying? Yeah, that's it. That's the game. What did you want to? Legal moves. Right. Unwinnable. It should generate a winnable game with any seed. That must be how they do it, is they play the game backwards because, well, no, I guess not necessarily. Yo, did Did we get any shorter games? This should be nicer. No way. Let's see, what's this? We got 2 games. That looks also 86. 84. No way. All right, what's the biggest number now? 277 was the most common game. Still not like center mass. It's interesting. Win rate 6%. 104. What was it before? 108. Something had to be predetermined. The game was running perfectly on Windows XP with barely any RAM. Well, it wasn't self-solving. It was just generating the game. What I'm doing here is solving the game. I'm exhaustively searching every single game state. I think I want to make a little trait. That's right. Okay. La 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 la. Okay. You go back. You go back. Okay, so I want to say can I rap? Wait a minute. I guess I could. I could just iter. Okay, I'm gonna say this is iter. Oh. Help. Okay, yeah. Okay. So iter. There you go, bud. And then if we say this is get sorted moves into iter. Now the iteration order is better. Help. Okay. It might be able to. So like, this is now doing a heap allocation, which is slow. But I'm curious to see if it's faster overall. Wait. Oh, 133. Haul up. Is that the winnable one? 123. So this should still... Yeah. So it's just... Better iter order. Nice. Better iter order. Iter order. Better iter order. Come back. Bring it back, y'all. All right, let me see what's going on again. Oh, right, it does this. Yeah, look at how many fewer states it went through. So if we go back to this comment, actually, why don't I make this little branch? Order. Help. So this branch, look at how many states it observes. It observes 8,000 states, and it goes for 20,000 moves. Whereas this one, oh, interesting. The number of moves is still kind of high. Interesting. But it's picking better moves. 12.5. Yeah, so it is actually faster overall. Interesting. What about... Okay, we saw this one takes a long time. So let's go to 133. Okay, so I thought it would be fast. So we actually have it written down here. 64 million. We passed that. No, we didn't. Ah, okay, so it took about half the amount with 124 moves. What about observed states? 2 million, 3 million. So it's a bit better. Interesting. So it's not any better at finding or proving that the game is not winnable, because you have to explore all possible game states, which takes a long time unless the game ends very early. I don't actually know what the upper bound is. Almost 2 times better. I was expecting much more. S 32 million moves. Jesus. This game uses 2 megabytes of RAM. I thought it was 2 kilobytes, but I think it's megabytes. A little bit upsetting. The card game. It's a card game. Klondike CLI. So it's using 2240 memory. Can I like set up? Display options. Is there an option that is there an option that says like human numbers, human music? No. So it just says kilobytes, and you just have to know that. So like this is 9 megabytes. Is that real? Where's the apps? Yeah. Memory 9 megabytes. I thought I was using kilobytes. I was so excited. So my stupid game uses megabytes. That's probably like the executable itself, mostly. We don't get that C level memory optimization without more effort. Yeah, so this is the command line game, main loop. It just parses what you want to do and then does it. Get auto move. No way. Hint. There's freaking hint H. It just tells you, it just prints it out. Oh, you can move the foundation. No way. Yeah. Is there a way to see executable RAM usage and code RAM usage? Only see the usage in total. I'm sure there is a way, but I don't know how to do it. Yeah. Oh. I wonder if you... Whoa. What if you inject foundation moves to make the game harder? Okay. Listen to this. So, like, you have difficulties while you're generating the game. So, in order to generate the game, you start with all the cards in the foundation and you play backwards. And I can just use the code that already exists because I have this function... is valid move, right? Or whatever the hell it's called. Is instruction valid? Sure, whatever you say, bud. So, like, you can just generate random moves, but and like include harder moves and harder difficulties. So like you're like, so in the easiest difficulty, you only take cards out of the foundation or something. And then in the next step up, you like start moving cards around the tableau. And then in the next difficulty up, I don't know, but like the max difficulty would be like moving cards in and out of the foundation. I don't know how you would like end up with a full board though. I guess you could like have sort of a shuffle duration to make it more random. So literally just do actual random moves. The problem is I don't have a function to generate moves backwards. Oh, that's easy actually. Right. I just do Klondike iter and then is move valid and then just do the move backwards. So process instruction, just make a backwards version of this function. That takes, yeah, easy clap. I wonder if I could even flip down the cards. It doesn't really matter because you can do that afterwards. It's cool. It's cool. That's definitely how to generate different difficulties of games. That you have like a mixing period. We have to use undo. It's always possible. I like it. I like it. I'm gonna open an issue. Play backwards to generate games. Also include a difficulty enum. Easy. Only move to foundation. Medium. Well, that's like baby. Cakewalk. Easy. Move from foundation and tableau to tableau. Peaceful. Categories, I guess. Stock. Oops. Legal. Generate moves. I guess you would include Tableau, stock to Tableau as well. Yeah. Yeah, it'd still be a cakewalk. Yeah. Okay, and then medium includes I don't know, maybe that's everything. Foundation. So move out of foundation. So do like 10 moves of churn or something. And then hard, 20 moves of churn. Expert. Well, we do like random. 50 moves churn. Random. We do 10,000. Just like every move is possible. Something like that. Expert. Random. I don't know. How does it like ensure that all the cards get distributed out into the tableau and stock though? Maybe it's like this. Do do do. So tableau to tableau. So eventually, I have no idea, man. Oh, it's an idea. Difficulty peaceful. That's funny. Maybe I'll change that. Peaceful. It's very good analogy. Card games are so fun to make. So fun to think of. Gotta go work on my website. Good luck with all of this. See ya. Thanks for the suggestions and the banter. Welcome to card game. Oh my goodness. So what if I play no. I'm really pleased that the algorithm actually did something. It's like fully general across any card game too. Just doing. It's a freaking state machine. Any possible state machine, it'll try to win. It just has a combinatorial complexity problem. Ayya, ayya. Oh yeah, this thing. Uh, overflow. What song was that? So, the algorithm technically works. It's just that the game shouldn't freeze for 5 minutes while it calculates whether it's possible to win or not, to give you a hint. Also, oh. State.undo. Indeed. It'll keep undo. Well, no, that's true. That's true, actually. Winning could include undoing your moves. Yeah, I wonder what the upper bound on like winning the game is. Ooh. So, okay, this becomes scanning all possible game states becomes less of a problem when the game is generated in such a way that there's guaranteed to be a win path. It can still be hard to find, though. Wait. Oh, obviously. We generated the game. We know what moves to make. You play the game from both sides. Oh, okay. I see. You don't need to do this. You don't need to scan all the states. You already know what the sequence of moves to win is. So you just need to find like a connection between the two states. You can't. I'm thinking. So like matching tableau cards. So think about this. As you've played the game a certain amount, and it also remembers how it generated the game you're playing. So it's like spraying the cards into the tableaus, one move at a time. It can like keep unwinding the game until it stops matching your current state. And use that as like the beginning and then the end of the connection points that it needs to find a path between. It's kind of, but it might be possible in another way. amazing band evasion. Yeah. So earlier I was trying to invent a better paradigm for the algorithm that walks through the game states of like you have two moves that are that don't affect each other. Like let's say you can move a card here and you can move a card here. Like you could do those in either way and it would just you would end up in the same place. Whether you did this one first or whether you did that one first, as long as you did both moves, you end up in the same state. So they're like orthogonal game paths. It's kind of hard to keep track of. Yeah. It's a much more interesting problem than I gave it credit for. To like find the way to win the game, or whether it's even winnable in the first place. I'm shocked. I'm shocked that it actually completes the search for through all possible states. All possible states. Wow. Oh. I know there's a two of clubs. Well, do I have more energy? Quite pleased with. Wait. I'm quite pleased. I actually made the algorithm work even if I didn't change the way I think about it. It's a lot more elegant and it's a lot more and it reuses the moves for each state. It actually it does exhaustively, like it didn't actually. Oh no, I guess it did exhaustively go through all states before, but it would rerun moves it's already ran. It's more elegant. Elegant is good. We like elegant. Elegant. 4, 3. Oh. 1, 2, 3, 4. Where's number 2? I think we're kind of cooked here. This is not a winner. Rah. You're 7. Don't got a 7. That's an L. Alright, I'm going to the stream. Cool stuff. Card game has depth. This code is technically open source. I might like push it to GitHub as well. Actually, why don't I do that now? I'll just put it on GitHub. Oh. Yet another card game library. Did I say library? Alright, let's go. Oh yeah, oh yeah. What? Oh. Cool. Okay. So it was hosted on my my friend's private. Wait, there's no README, brother. Yeah. This is cool. Card game. Got a deck. Pop the top card. There it is. It's a card. A 1,000 moves. We discovered that 200 is enough. Alright, well there it is. There's the code. If you want to look at the code. Enjoy. So long. See you tomorrow.